Welcome back, friends. In today's class, we'll talk about some more complicated problems on forces. Basically, we'll talk about the second law of Newton's second law of motion. So Newton's second law of motion, if I have to express it in the mathematical form, it is equal to, it says F net is equal to sum of rest of the forces, and F net is also equal to mass times acceleration. So if I combine this equation 1 and 2, I can say that ma is equal to sum of the rest of the forces. So it can be F1 plus F2 plus F3 and so on and so forth. That is in accordance with the Newton's second law. So let's take an example. So if this is an object having the mass m placed on the ground, and if I apply the force applied, F applied is equal to, let's say 100 newtons in the forward direction, and then force of friction acting in the opposite direction is, this force of friction is 60 newtons. I wanted to find out what will be the acceleration of this body. So I'll say F net is equal to force applied plus minus force of friction, and this value is equal to 100 plus minus 60, which is equal to F net. I've considered this negative because this 60 is acting in the opposite direction. So this value will be equal to 40 newtons, F net, and F net is equal to mass times acceleration. This is 40 newtons. Acceleration value will be 40 divided by 10, will be 4 meters per second square in the forward direction, because this is a positive, so this is also forward or east, you can call it. So that's how we can find the acceleration of the object. Now we'll talk about some more complicated problems on the forces. So let's say there's an object placed on the ground. So force of friction, which always acts in the opposite direction, force of friction depends upon the surface roughness. So what do I mean by surface roughness? Let's say this object of mass m is placed on the surface, on a rubber surface. The surface is made up of rubber, some rubbery material, and you're trying to pull this mass m in the forward direction with some F applied force. Or in the other scenario, if this mass m is placed on a glass and you're trying to apply some force in the forward direction, so naturally in this case 2 you will have to apply less force than case 1. So force of what we can conclude from that is that the force of friction which acts on any object depend upon the surface roughness. It depends upon some other factors also, but surface roughness is also one of the biggest factors which decides the magnitude of the force of friction. Now let's talk about how can we calculate the magnitude of force of friction. So force of friction, to calculate the force of friction, I'm going to again draw the diagram. This is a body of mass m. So force due to gravity always acts in the downward direction. So this will be Fg, which is equal to mass times gravity. And then because of this, there will be an equal and opposite force. According to Newton's third law, we've already talked about Newton's third law in last video. So Newton's third law says every action has an equal and opposite reaction. So if this mass m is applying a force of mg in the downward direction, then this surface will also apply an equal and opposite amount of force on this mass. So that is called normal force. And Fg, let's say the applied force is in the forward direction, so Fg will act in the opposite direction, Fg, and that will be equal to mu times normal force, and this is equal to Fg max. So not Fg, this will be equal to F, force of friction max. I'll also talk about in detail what is the difference between force of friction max and force of friction. So for the timing, just get to know that this is the formula to calculate what is the maximum force of friction which will act between a body and the surface. Now let's try and calculate what is the force of friction maximum which is acting on this body. So before that, I haven't talked about this mu value. This mu is called coefficient of friction. Coefficient of friction. So now let's say there's a body of mass 10 kgs, and then what is the force due to gravity? Fg, which is equal to 10 times, I'm going to assume G value as 10 just to make my calculations easy. This will be 100 newtons in the downward direction, and this is Fn, which is acting on the opposite direction, and this value will be equal to Fn value will be equal to Fg. So this will be 100 in the opposite direction, and force of friction max, we've said this is equal to mu times Fn. So we were talking about this coefficient of friction. Coefficient of friction depends upon the surfaces, as earlier I was talking about. Then if the object is placed on this metal surface, or the object is placed on a rubbery surface, the coefficient of friction, the friction on this surface will be more compared to the friction on this surface. Because why? Because the coefficient of friction on this surface will be more as compared to when the object is trying to slide on this surface. And the coefficient of friction is also a unitless quantity. So let's talk about force of friction value in this. Let's assume coefficient of friction given to us in this question is 0.5, and this is 0.5 times what is the force of friction, which will be 100 newtons. So this force of friction value will be equal to 50 newtons. So this is the maximum force of friction which can act on this surface. Now, keeping this concept in the mind, let's say there is a body of mass 10 kgs, same body, mass of 10 kgs, and I'm applying a force of 30 newtons in the forward direction. And I wanted to find what is the force of friction acting on this body. In this scenario, the force of friction which will act on the body will be 30 newton, because we also have to make sure that we are abiding by the Newton's third law. If I'm applying forward force of 30 newton, force of friction will be 30 newtons, and we're taking the same surfaces as from this previous question. We've already figured out that force of friction max is 50 newtons, so it means you have to apply 51 newtons for this object to move, but I was applying only 30 newton of force in the forward direction. So you'll agree that I won't be able to move this object in the forward direction. So but I still wanted to find what is the force of friction. So if I'm applying 30 newton of force, the force of friction which will act in the opposite direction will be equal to 30 newton. And if I'm applying, let's say 40 newton, still the force of friction will be equal to 40 newton. I'm applying 49 newton, the force of friction value will be equal to 49 newton. Now I start applying same object, same surfaces, 10 kg object, I apply a force of 60 newton in the forward direction. The maximum force of friction which can apply is equal to 50 newton. So now you've crossed that barrier. Now rest of the 10 newton force will make this object move in the forward direction. That will convert it into F net. F net will be equal to force applied plus minus force of friction max, and the force of friction max is 50 newtons. So when to use this formula, force of friction max, if you are given the coefficient of friction, or you are asked to find the coefficient of friction, then you will use the force of friction max formula. Always remember this thing. So this is really important concept where the student made a mistake. Student always think that we've calculated the force of friction max, so this is the force of friction also. There's a difference between force of friction and force of friction max. Force of friction max is the maximum force of friction which can apply between the object and the surface. So this value will be equal to, so I applied 60 newton minus 50, that is F net. So this will give me 10, F net comes out to be 10 newton. F net, and if I wanted to do it in detail, I can write it as mass times acceleration, which is equal to 10 and I can find the acceleration of the object also. So I'm not going to do that thing right now. I'll leave that up to you guys. Acceleration will come out to be 1 meters per second square for this question. So let's talk about the formula now. So you might have seen that I'm applying this F net formula as F applied plus minus force of friction. So this is basically a standard formula which we use when we are trying to pull the object in the forward direction on a horizontal plane. So if this is a horizontal plane and there is an object placed on this one, a force is being applied in the forward direction. This is applied. What will act in the opposite direction? Only force of friction. So that's where I've used the negative sign here. All right, and then that will give me, this formula will give me the net force. Now repeating again, if you are given the coefficient of friction, then this formula will change to force of friction max. Rest everything will remain same. So hopefully you were able to understand something about when you're applying, this is F net. Hopefully you were able to understand something about the Newton's second law when the object is placed on a horizontal surface. In the next video we'll talk about when the object is placed on the inclined plane. So thank you, bye now. Oops.